Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to measure face distance in between a normal USB web camera and our face. So we are going to use a face detection module mediapipe on Raspberry Pi 4 Raspbian OS Bullseye 64-bit version. But before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, we are going to use mediapipe face detection module, and with the help of mediapipe we are going to measure a face distance in between our USB web camera and our face. For that, first you need a latest Raspbian OS 64-bit version. As you can see, this is what Raspberry Pi 4 raspberrypi.com official website, and Raspberry Pi OS 64-bit. This is the latest version. As you can see, the release date is May 3rd 2023, and this is the 64-bit version Raspberry Pi OS with desktop. So we need this latest version, a 64-bit version. So I have already installed the latest version. Then we need here a mediapipe on our Raspbian OS Bullseye. So how to install mediapipe? I have already created the video. I will mention video link, watch video and install latest mediapipe and TensorFlow Lite on Raspbian OS Bullseye 64-bit version, this version. So I have done with package installation. For today's session, I have created a new repository, and the name of repository is rpi4 mediapipe face distance. I will mention link inside description box. Simply copy and paste the link inside the browser. Then go to the code and just copy the link from here. Just copy it, open terminal, and let me make a zoom in. So just zoom in for better clarity. Okay, so we copy our link. So now simply run the command git clone and paste the link of our repository and just hit enter. It will clone our repository. Now we have our repository inside our home folder. So just go here, file manager, and as you can see, this is what our repository. So inside that repository, as you can see, we have face.py and we have img.py. Face.py is our main code for face detection with the help of mediapipe, and img.py is basically the code which start our USB web camera and it will capture our face image. Simple. So let's just open both code with the help of our Thony. So menu, programming, Thony. And this is what our Thony. Just close the untitled file, go to the file, click on open, and go to the pi and rpi4 mediapipe face distance. First let's just open face.py, and this is the basic code for face detection with the help of mediapipe, which I have already explained in previous video. So if I start the code over here, we will have the face detection. We have basically the rectangle on our face. I have connected the USB web camera with Raspberry Pi 4. As you can see, it's detecting my face. There is a rectangle on my face. It means our mediapipe is perfectly working with detecting the face. Simple. So now go to the file, click on open, and img.py. So img.py is basically the code for only starting the web camera. So if I start the code, it will start a normal frame. There is no detection and nothing. Okay, it's just a normal frame. And if you press here A button, as you can see, press A. If you press here A button from keyboard, it will capture the image and it will save the image in same repository where we have face.py and our img.py. Simple. So just stop the code. So first what we want here, just open our face.py, and here we want to add some more function for measuring the face distance. So for that, first we need a known distance from our USB web camera to our face and known width of our face in real world, real time. So let's just create two variable, known distance and known width. Okay, so this is the known distance from our USB web camera to our face, and this is the face width in real world, in real time. So simply what we are going to do, just open img.py and start the code. So friends, as you can see, this is what a measurement tape, a simple measurement tape. As you can see, a simple measurement tape. So what we are going to do, I have mounted the USB web camera on my monitor at the center point, okay. Now what we are going to do, we want to measure the distance from USB web camera to our face using this measurement tape. So just measure the distance as we always measure any distance, okay, like this way. Simply I have touched the starting point to USB web camera. So from USB web camera to my face, distance is basically 64 centimeters. So just mention here distance is 64 centimeter. So as I mentioned, just measure the distance as we always measure any normal distance from one object to another object. So here we have our USB web camera and our face. So from USB web camera to our face, use the measurement tape and measure the distance and mention the distance as the known distance. Now next thing, simply again start the frame with img.py and again take the measurement tape and just measure your face width and mention the known width. So let's just measure like this way. So in my case, my face width is basically 14 centimeter. That's it, we have done. Now what we want here, the code is running, the img.py is running. As you can see, we have here frame. So now we have our known distance, we have our known width. Now simply we want a snapshot of our face. So simply, as I mentioned, just press the A button from keyboard and it will capture your image and it will save the image inside same repository. That's it. So let's just capture the image. So friends, I have pressed the A button, as you can see, and if I open file manager, this is what our repository, and inside that repository, as you can see, we have here a snapshot. Simple. rf.png is the image name. That's it. So we have done with first step. Now simply let's just create our function. So let's start. Def, we need here a focal length. So F capital focal underscore length underscore finder, let's say focal length finder. This is what our function name, and this function object is basically known distance, known width, and we have here our reference image which we capture with the help of our img.py, and we save the image inside our same repository. So we need here reference image width, because inside our reference image we have our face. So we want here a reference image face width in pixel. So for focal length finder, the object is basically known distance, then we need here known width. Then what else we want? As I mentioned, we want reference image face width. So let's just say face width rf img. Okay, face width in rf img means the face width in reference image in pixel format. Simple. So this is what our objects for focal length finder function. So now focal length focal length. What is focal length? So focal length is basically our face width RF image multiplied by known distance divided by known width. So let's just mention face underscore width underscore RF underscore IMG, then multiply by known underscore distance. Okay, face width RF IMG multiply by known distance divided by known underscore width. That's it. Then simply return what we want. We want to return our focal length. So focal underscore length. Okay, I hope you all clear. So this is the function for focal length finder. We need a reference image face width. We have here known distance, we have here known width, which we just measure with the help of any normal measurement tape in real world. Simple. I hope you all clear so far. So inside object data function, this is what our mediapipe face detection function, where we have x, y, w, h, and with the help of x, y, w, h, of course we can draw the rectangle on the face. Means first we detect our face with the help of mediapipe. As you can see, we have here b box is equal to detection dot location underscore data dot relative underscore bounding underscore box. This is the method for getting the x, y, w, h coordinates. Simple. So now we have x, y, w, h coordinates. So this w is our face width in pixel format. Why? Because when we detect the face, how we can say that we are detecting the face? For that we are basically drawing the rectangle on the face. So rectangle width is basically our face width in this case. So this w is basically our object width. So in today's project, our object is basically our face. So simply we want to mention the object width is basically this w. But when we start our code, in that time we don't know what is the width, means here. So here we want to say obj width, obj underscore width means object width is equal to 0. Then here what we want to do, when we have detection, we want to mention here obj underscore width is equal to our w, because this w is basically our width in pixel format. That's it. So then simply we want to mention return obj width. So where we have for loop started here, so in that line we want to mention return obj underscore width. That's it. So now we have our face width in pixel format, because we have mediapipe face detection model, and with the help of mediapipe we successfully draw the rectangle on the face. So our rectangle w coordinate is basically our face width in pixel format. That's it. So then what we want our distance for live frame, means when we start our web camera in while loop. So let's just say def distance d capital underscore distance finder. This is what our function name, and distance finder function object is basically focal length, then the known width, and when we start our camera, when we start our USB web camera in while loop, in that time also we have mediapipe face detection. So we want here face width in live frame. We have here face width in reference image, but when we start our USB web camera in live frame, in that time also we want our face width. So simply here we want to mention the object for distance finder. As I mentioned, first we need a focal length, so mention focal length. Then we need a known width of our face, which we mention as a 14 centimeter with the help of our measurement tape. in real world. So known width, then as I mentioned, distance finder is function basically we are going to call when we start our web camera in while loop. So in that time also we want our face width in pixel format. So simply we are going to mention face width live frame. Live frames in the sense when we start our USB web camera in while loop. So I have mentioned face width in live frame. This is for our knowing purpose. Okay, that's it, we have done. Now what we want here, we want to mention the distance method. Distance is equal to what? Distance is equal to known width multiplied by focal length divided by face width in live frame. So just mention known width multiplied by focal length and divided by face width in live frame. Okay, that's it. Now simply we want to return our distance. That's it, return distance. Now we have done with function. Now simply we are going to use this function. So first we want here a focal length. So how do we get the focal length? So focal length is basically known distance and known width which we have here. As you can see, the known distance is 64 centimeter, which we measure with the help of normal measurement tape. Simple. So 64 centimeter is the distance from USB web camera to my face in real world, and the known width is 14 centimeter. So we have known distance and known width, but we need here face width in RF image. So face width in RF image means the face width in reference image in pixel format. So we have here object width in pixel format. So simply we want to call our image, our rf.png image with the help of cv2.imread, and simply we want to pass that image inside our object data function. Then we will get our object width, means the face width in reference image in pixel format. Simple. So let's just call our image. So let's say rf underscore image is equal to cv2.imread function, and inside that we want to mention our image name, which I have already shown you, rf.png. Simple. So rf.png. So now we have our image inside our rf underscore image variable. So simply we want to mention here our object, which is face width rf img. So just copy it, copy and just paste here. So this is what our face width in rf img is equal to what? Is equal to our function, which is object data. So obj underscore data, and inside that we need to pass our rf underscore image variable. Rf underscore, that's it. Simple. Now we have our face width in rf img. So now we have our all three object ready. So simply we can call our focal length finder function for focal length, because we want to measure here distance. So for distance we need a focal length. So now simply mention here focal length. Focal length is equal to our focal length finder function. So just copy it and just paste here. That's it. Now we have our focal length. Now simply we can get our distance. So we have focal length, we have known width. Now we just want here face width in live frame. Simply when we have a cv2 resize function in while loop, after that again we need to simply mention object within frame. Simple. And this object within frame is basically our face within live frame, and simply we want to call our object data function and just pass our frame. So here the variable which I am going to change with our object name, which is this one, for our knowing purpose. Just copy it, because when we start our USB web camera in while loop, we have face detection, so we need face within live frame in pixel format. So for that we need to call our object data function, and inside that we need to simply pass our live frame. Then we have our face within live frame. Done. So now let's just create the if else condition. Means if there is no face, of course there is no need to face with live frame, then just mention no face. Else we want to measure the distance. So if not face underscore width underscore live underscore frame. Okay. If not face width in live frame, just print no face. And then else simply call our distance finder function. Just copy it and just paste here. Simple. So we have focal length. We have focal length here. We have known width, which is here. Our face width in real world, in real time, which is 14 centimeter in my case. And then we have face width in live frame, which is here. Simple. So now simply we can print our distance. So here I need to mention a distance is equal to our distance finder function. So if I save the code, if I run the code, it will start a live frame, and then we have the distance. Oh, I forgot to mention underscore here. Just a minute. Face width live frame, face width live frame. Just a minute, let me start again the code. There is an error in variable. It says name face width live frame is not defined. Oh, here in distance is equal to known width here in function here. I forget to mention here underscore. That's why there is error. Simple. So now if I start the code, and as you can see friends, it started our live frame, and inside the shell, as you can see, we have distance. So right now the distance is basically 71, okay, 72, or if I go back, the distance is 89. If I come close to the camera, of course the distance is 53 or 54 centimeter. That's it. So we successfully measure the distance using our USB web camera, our normal USB web camera. So now we have our distance. Now what we want to do here, we have a rectangle on our face. So we want to mention this distance on a rectangle top left corner. For that we need here our rectangle top left XY coordinates. So simply here what I am going to do, I will create a list. So a dot append, a is just a list name, and a dot append a dot, just a minute, a dot append, and we want to create the XY coordinate list. A dot append, and this XY we want to pass as a list, and here I will call a is equal to empty list. Now I can call the a list anywhere. So here let's just say for I in our a list. So if I print here our I, Just save the code and run the code. So as you can see friends, we have here x and y coordinates, this one, the rectangle top left coordinates. So the index number is basically 0 and the 1. So 0 and 1. So 0 is basically our x1 and 1 is basically our y1. So simply we can mention here like this way: x1 is equal to I, the 0 index, and y1 is equal to I, first index. That's it. Now we have our x1 and y1 ready. So where we start our for loop, in this line we can simply mention cvzone dot put text rect method. So for that I have mentioned here cvzone. Simply go to the tools, manage packages, search for cvzone, just click on search on PyPy, cvzone, the typo mistake, cvzone is the package name, not ccvzone, cvzone. Click on cvzone and click on install. That's it. It will install cvzone on our Raspberry OS Bullseye. That's it. We have done. Now simply, where is our cvzone? Here. Here we want to mention cvzone put text rect method, and then simply we want to pass our distance variable. Then it will put our distance text on our rectangle top left corner, because now we have our x1 and y1, which is our rectangle top left coordinates. So where we have our for loop line here, just check it is in line, cvzone dot put t capital text r capital rect. Then where we want to put the text, we want to put the text on our frame. Then in this way we want to mention the variable, okay, our distance variable. But first we want to mention the text, means the distance is just the text. Then we want to mention our distance variable. So let's just like this way, in single quote d capital distance, this is just a text name, distance shift colon. After that we are going to mention our distance in round format. So like this way, round. Here we want to pass our distance variable, which is our real time distance, which basically we measuring. So distance, and after that here after single quote again we want to mention the coordinates, means the x1 and the y1 top left rectangle coordinates, and then we want to mention 1 and 1, the rectangle size and the text size. So if I save the code, if I run the code, and as you can see friends, as I mentioned, we successfully put our distance measurement on our rectangle top left corner, and distance is just a text, and this is what our distance in centimeter. As you can see, 67, 64. If I go back, it will increase. It's now 90, 91. If I come close to the camera, it's say 49, 50. Simple. So if you want to make this square box, the rectangle box size bigger, simply what we want to do, we want to mention here 2 and the text size also 2. If I save the code, if I run the code, and as you can see now, the rectangle size is increased, also the text size is also increased. Simple. So we successfully measure the distance using normal USB web camera with the help of mediapipe module on our Raspberry Pi 4 Raspberry OS Bullseye, latest Raspberry OS Bullseye. So I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.